Hello everybody, my name is Marco, and today we are going to talk about OOP, or Object-Oriented Programming. This is a tool or a paradigm that represents a concept as objects that have some data fields. Also, you can manage to do a lot of things with OOP. For example, if you imagine some sort of the way that the nature works, right? You can put it into a code. It's incredible how OOP allow us to interpret the nature in a code of our applications. So this is a very important tool, and a lot of programming tools use it. For example, Java, C#, just to mention some of them. So I think that this is a pretty interesting theme that a lot of people already know, but a lot of people don't know it as well. So I hope you like this video, and I hope you like the next part. Thanks for watching.
History. We will be talking about history of the object-oriented programming. Terminology invoking objects and oriented in the modern sense of objects-oriented programming made its first appearance in MIT in the late 50s and early 60s. In the environment of the Artificial Intelligence Group, as early as 1960, object could refer to identify items, list atoms with properties attributes. Alan Kay was later to cite a detailed understanding of Lisp's internal as a strong influence on his thinking in 1966. The formal programming concept of objects was introduced in the 1960s in Simula 67, a minor revision of Simula 1, a programming language designed for discrete event simulation, created by Ole Hollandel and Christian Nair of the Norwegian Computing Center in Oslo. Next, the Smalltalk language, which was developed at Ceres Park in the 1970s, introduced the term object-oriented programming to represent the persuasive use of objects and messages as the basis for computation. After that, in 1985, Bertrand Meyer produced the fifth designer of Eiffel language, focused on software quality. Eiffel is among the purely object-oriented language, but differs in the sense that the language itself is not only a programming language, but a notation supporting the entire software life cycle.
I will talk about some important terms in this type of programming. The term number one, the class. A class is the definition of the attributes and behavior of some objects that we need in the future in our program. It's like a template for future objects. Another term is a test. It's the generic term of attributes between two classes or more classes. Like, for example, a class C inherits its attributes and behavior to class B. It means the class B now has all properties in behavior now. An object. An object is often called as an instance of a class because the instantiation is the creation of an unique object in the world of a program with all the properties from some classes previously defined. Another term is the method. A method is the behavior related to an object defined in a class previously. These are the actions that the object can do. The action can modify the attributes of the object. An event. An event is such as user interaction with the machine, and is an action generated because two or more objects are interacting. The attributes are the characteristics that an object can have, are the features of an object. Another term is a message. A message is a communication between two objects. It is the way that the object can interact in the system. Another characteristic is the components of an object. There are the attributes, identity, relationships, and methods.
Hello, my name is Alfredo. and today I'm going to talk you about some characteristics of OOP. The first one is the encapsulation. So in OOP, the objects interact with each other by messages. The only thing that an object known about another object is the object interface, right? So in other words, the interface encapsulates the object code and data. This is the first principle of the OOP. The second characteristic is the inheritance. So in OOP, the classes are created in hierarchies, and inheritance lets the structure to and methods in one class pass down to the hierarchy. That means less programming are required when you are adding functions to a complex system. This ability of reuse the existing objects is considered a major advantage of object technology. The last characteristic is the polymorphism. The polymorphism means having several different forms. So polymorphism is related to object methods. So the polymorphism allows you to create a particular response to one type of message that varies depending on its parameters, right? Thanks.